Hello all, my name is Charlie Westphal and I'm going to be talking to you about feature selection for network intrusion detection. Network data is comprised of a large number of features of varying quality, so selecting from them is becoming common practice. We noticed 4 recurring issues with current methods of selection. Firstly, the complexity problem. So we want our selection method to scale linear in time with respect to the number of features, therefore we can investigate highly dimensional spaces. Secondly, we want our method to establish a feature number rather than leave it as a hyperparameter for tuning. Thirdly, our method needs to be able to work in the presence of highly redundant information. And finally, it's been well established in the intrusion detection literature that incorporating temporal relationships into your classification task can improve accuracy. So let's try and leverage these relationships when selecting features. Our solution is FSNID. So in FSNID, we sequentially evaluate this condition, which roughly quantifies the extra information a variable xi provides when included in the set X. If this value is 0, we remove this feature. If it's larger than 0, the feature is included. How does this solve the problems we discussed? So firstly and simply, phi is calculated once per feature, and therefore the complexity is linear in time. Secondly, a feature is included if phi is verified and not otherwise. Therefore, features are included based on those already selected, rather than features just being included up to a predetermined value. Thirdly, the redundancy problem. FSNID overcomes the redundancy problem by, upon encountering redundant features, removing them so that they no longer provide redundant information about the remaining features in the set. And finally, the temporal relationships problem. Basically, the conditional entropies we used to describe our condition can be rewritten as a supramarm over a set of functions and therefore can be approximated using classic function approximation. Therefore, any technique used to improve our classification function approximator can also be incorporated into our condition approximation. And there we go, that's how we overcome these 4 problems. And then this leads us to some results where we show that we outperform baselines when selecting features. And that's it, and thank you for listening.